what'd I do?
Subtract the 4.
And what's the A, B, and the C?
A plus 2,
B
-3,
and C.
-4.
So putting it into the formula, it's the opposite of B plus or minus the square root of B squared minus 4 times A times C over 2 times A. Everybody remember your formula?
Yeah.
Okay, now what do you get underneath the radical? Yes. But remember we have just this hour. So I have 8, 32, 41. Anybody else get 41? Everybody agree there? So that would be our answer, wouldn't it? Because 41 doesn't simplify, and we can't reduce anything. Is everybody okay with that one? Do you guys need more on the quadratic?
No.
Okay, and remember you can practice these again on that review sheet I already had handed out. Synthetic division to find all roots. So I already have an example up here. The power is 3, so that means you should have 3 roots. So this is find all roots. Now, what are factors of 12? 1, 12, 2, 6, 3, and 4. You guys agree? So which one do you want to try? Remember, this is where you do it's kind of like the lottery is what I call it. Because you got to keep on trying until you find one that works, that goes to a remainder of 0. Which one do you want to try? 3, 2, which one? 3. So if we divide synthetically by 3, remember to do synthetic, you just add and multiply, add and multiply, add and multiply all the way through. So what will I get when I add?
3.
Well, you get 1 first, right?
1.
Then times 3 is?
3.
Then you add,
6.
multiply,
18.
add,
14.
times 3, and I can already tell you it's not going to work.
42.
We don't get a remainder of 0, right? So 3 didn't work. Could a negative 3 work?
Maybe.
Let's try it, since that way I can eliminate them. So it'd be 1 times negative 3 is 0. What's negative 3 times 0? Add negative 4 times negative 3 is 12, and what did we just find? Negative 3 is one of the roots, so negative 3 is a root. Now, doesn't that leave me, what's my answer for that synthetic division? 1 less power than what you started with when you x squared minus 4. Now, couldn't you solve that by another method at this point?
What you just do? What are we at?
This is when you divide synthetically, when you divide, your answer is 1 less power than what you started with. So we started with x cubed, so this would be an x squared plus 0x, so I don't need to write it, minus 4.
I don't understand.
When you divide synthetically, what you get, like on this one right here, this would be 1x squared plus 6x plus 14, but you have a remainder of 30. It's always 1 less power than what you started with.
What you just write though? You just wrote the thing out on it.
Down here,
Yeah.
I did the same thing. This is 1x squared plus 0x, which you don't have to write because it's a 0, minus 4, and then that's factorable. So that saves you some time. Because can I tell what the root is from that? X would be 2, and x would be a negative 2. So the roots of this problem is a negative 3, 2, and a negative 2. And we have 3 answers. So basically, you only have to do synthetic division to find one, and then you can find the others by using your quadratic formula or factoring, can't you? Okay, does everybody follow what that group is? Now, what's next on the list?
Find inverse function.
Okay, so inverse and composition I'm gonna do together. So let's first find the inverse. So I'm gonna find the inverse of the f function. What's f of x? F of x another way of saying?
Y equals.
Y equals. So I have y equals 3x plus 5. To find an inverse, you swap your variables. So that means you're sharing places. So first step is to swap. So what will I get? X equals 3y plus 5. I swap the variables. Then the second step is to solve for y. What would I do to solve that for y? Subtract 5. And divide by 3. So 1/3 x minus 5/3 equal y is the inverse function. And you can always check an inverse. Do you guys remember how to check them? Yes, Nicholas?
I was wondering if you could write that to the 3 over the x minus y.
Yeah, you could do that. I mean, just have it all over 3 if that's what you're asking me. If you wanted to check it, pick some number. 0's easy. If I put 0 into the original, what do you get?
5.
So that means in this, if this is in true the inverse, then the 0.50 should work, right? What's 1/3 times 5? Is 5/3 minus 5/3 0?
Yes.
So it checks. So you can always do that. Pick any point, put it in the original, and then the inverse of that should work in the inverse function. Now, composition function. F, the little degree symbol is composition. That's F composition g of x, which can also be written this way, which sometimes I write it that way because that way it makes it easier to understand. This means you're putting the g function inside the f function. So f of my g function is 4x minus 2. What would I do to substitute that into the f function? And when you substitute it in, you always put it in place of x. So when I put that in place of x, what will I get?
Where'd you get f?
Where'd I get what?
Where'd you get f out of?
Right here. F composition g of x. That's the way you write a composition function. So the f stayed there. This is another way is putting brackets instead of using the degree symbol. And then g of x is really 4x minus 2. And now what do I need to do?
It's not g, it's f.
This is g of x. G of x is 4x minus 2. Now we need to put 4x minus 2 into the f equation in place of x. So it'll be 3 times 4x minus 2 plus 5.
Mm-hmm.
So what do we get?
12x minus 6 plus 5. 12x minus 1.
And that is f composition g of x. So a composition function is where you put a function into another function. Okay, what's next on the list?
Finding.
Okay. Length and midpoint I'm going to do at the same time. So length, midpoint. So the length formula or distance formula is x minus x squared plus y minus y squared. So what are my x's?
Hold on.
So 3 subtract a negative 2. And what are my y's? So now what's 3 subtract?
5 plus 4 squared.
Okay, let Nicholas catch up. And then you guys can do what at this point? Square each of them and add them together. So again, it's just the distance formula, x minus x squared plus y minus y squared, and you add them together. So we're going to end up with what? 25 to the square root of 41? Okay, is everybody good on the distance formula? And that's the length formula. Midpoint, which you already have this in your other notes. Yes, sir.
Can we, like, on the distance formula, can we just go ahead and, like, get rid of the squares on it? Sorry.
At where? At this stage?
Yeah.
No, because you have to do what's in parentheses first, according to the order of operations.
But it's.
According to order of operations, you have to do what's inside. If you want to get rid of that squared first, you get 5 squared, you get 1 squared, and you aren't going to get the same answer.
The whole group squared.
Yeah.
We can keep the parentheses, but can't we, like, unsquare the group?
If it was multiplying, you know, it's fine.
No, it's an addition.
You're not like.
It's in addition. Okay, well, according to your order of operations, you always have to do what's in parentheses first. So you got to follow that order of operations still. And then you square it. And then it's underneath that radical, so we leave it there. Unless you can simplify it. Now, midpoint. What do you do to find a midpoint? All it is an average. Isn't that a mean? Add them together, divide by 2. Add them together, divide by 2. So I'm going to add my x's. So what are my x's? And my y's? So we're going to get 1/2, and 6 divided by 2 is 3. So you got one of each, one length and one midpoint. Basically, it's just following the formulas. What's the next on the list? Identify the conics. Okay, so I'm just going to give you some examples. You should have in your notebook the notes for each of them. Remember that a circle, both variables are squared and in addition, and the coefficients are the same. A parabola is the only one that only has one variable squared. A hyperbola, both variables are squared, but they're in subtraction. An ellipse, both variables are squared, but the coefficients are different. And how do you know a line?
It's like y equals mx.
There's no square. Okay, so that's what you're looking for. So if I give you, I'm going to give you 5 different ones, you tell me what it is, which is what you're doing on the final. All you're going to do is identify. Okay?
Oh, okay.
Does everybody follow what I'm saying there?
Yeah.
Yes.
That's a Y. I'll do a curlicue down there so you know. And again, on your final, all you're going to do is identify. Just tell me which it is. So that means you've got, what, a 20% chance of getting it right just by guessing?
Yeah.
1 out of 5. Which nobody should miss the line in my book. So that would be like a freebie point, right? Okay, so which one's the line in that group?
2x plus 4y.
Does everybody agree that's the line?
Yes.
Why do we know it's the line?
No square.
There's no square. Okay? Next one I'd look for is the parabola. Why? Only one of them squared. So which one only has one variable squared? This one? So that's the parabola. Now, the next one, both the circle, the ellipse, and the hyperbola are both variables are squared, but the hyperbola is the only one in subtraction. So I'd look for that one. The last one, x squared and y squared are in subtraction. Now, between the circle and the ellipse, how do you can tell the difference between them?
Circles all addition.
They're both in addition. Their coefficients are different if it's an ellipse. They're the same if it's a circle. So where do you see the same coefficients?
The second
Second one, okay? So this would be the circle,
and the top one's ellipse.
and that would have to be the ellipse because the coefficients are different. Okay. Now, then the next part of the test, it says pick one of the above and name all its parts and sketch a picture. Which one, except for the line. You can't do that one. That, it's worded in there. You can't do the line. So which one is the easiest after the line?
Circle.
Circle. So I would pick that one. X squared plus y squared minus 6x equals 1. And in order to graph it, you need to complete the square. So that means you group your x's together. You guys remember completing the square? We
So
practiced a little bit before your Kansas assessment too. Half the middle term,
3
square it.
9.
So if I add 9 here,
Add 9 on
you have to add 9 to the other side. Because you're in algebra, you do exactly the same thing to both sides. Now, what do we do with x squared minus 6x plus 9?
Just X.
That factors.
X.
Right, so that's x minus 3 quantity squared plus y squared equals 10. Now, does everybody follow where I got that?
Somewhat.
To get x squared is x times x. To get 9, it'd be 3 and 3. Or another way to remember, it's always half the middle term. Whatever's here, half of it's always going to be in both those positions. Now, what is the center of this circle?
The radius? No.
Let's do the center first. Change both of them, so this would be 3, and there's nothing with that, so that would be 0, right?
Well, how do you get a 3?
Change the sign of it. In other words, set it equal to 0. So if I have x minus 3 set to 0, what do you get? 3. And that's a y minus 0, which I don't have to write, but you could. So wouldn't that just be 0 for the y position?
It's
Yeah.
change,
Change. What's the radius? It's the square root of whatever the constant is. So it's the square root of 10. And I can't simplify that, so I'm good to go with it. Now, how do you sketch a circle?
You start
Let's
with
go
the
from
middle.
circle. Go 4.
It's north, south, east, and west, right?
Mm-hmm.
The center is at 3, 0, so I found that point first. What's the square root of 10?
It's somewhere between 3 and 4.
That's all you gotta do. Somewhere between 3 and 4. You don't have to have your calculator. You just have to go somewhere between 3 and 4, north, south, east, and west. So a little bit past 3. And it's just a sketch. So as long as you get the center right, and it looks to me like you went the same amount north, south, east, and west, you're good. So again, you found the center, and then you do the square root of the constant, which is the radius. Okay, is everybody okay with the conics? What's next after conics? Is it the rational?
Yes.
Multiplying. So first multiplying. Here's what you need to remember to do most importantly. Factor. So the key thing on multiplying is to factor. So how am I going to factor that expression?
The top one you can do x plus 3 x minus 3.
Difference of two squares, good.
The 4x minus 8 you can take out 4.
Take out what's in common.
The 2x minus plus 6 you can take out a 2.
And that's a trinomial, right?
Yeah.
What are factors of 6?
2 and 3.
1 and 6, 2 and 3, which of those, since the last term is positive, which of them will add to get you the 5?
Just -2 and -3.
Right, so -2 and -3. Now, once you have it factored, then you can cross cancel. So what can we cross cancel out?
Is x minus 2.
X minus 3, x minus 2, x plus 3, and 2 goes into 4 twice. So it looks like pretty much everything canceled. So we had good practice there on that one. So key is factor, and then once you factor, then you can cancel. Addition, what do you gotta do in order to add?
Common denominator.
I'll make that just x.
5 over
So what would I need for a common denominator?
+3.
And?
You need to multiply the first one by x.
Right, so we want x and x plus 3, right? So what do I gotta take the first, you already told me, I need to take the first one times x? What do I need to take the bottom one by?
+3.
X plus 3? So you would distribute and get 4x plus 12? What will that add to get us?
9x.
I can take out a 3, right? If you can factor, you can factor. Will it help me to factor that, though? So you could really leave it this way since nothing canceled when you got finished. So either one would be okay. All rational, right?
Yeah.
I don't know how nice this will come out, but we can do it. In order to solve a rational expression, you need to multiply by the common denominator. So what would our common denominator be? X squared, right? And,
3.
so we need 3x squared for each one. So here, the x will cancel x squared to x.
Do what?
Common denominator, you multiply by the common denominator, which was x squared. You take the largest of your variable, and then the number that was in common was 3. So 3x squared is what we're going to multiply each term by. Now, won't x go into x squared x times?
Yes.
So you have 3x times 2 is,
6x.
x squared cancels totally, so I have 3 times 3 is
9.
9.
3's cancel, so it'll be x squared.
Now, what would I do to solve that?
Subtract x squared.
Okay, so negative x squared plus 6x minus 9.
What?
You gotta get it equal to 0 so that you can solve, so they chose to subtract x squared. I'm one of those that would have subtracted 6x and add 9, because I don't like negative x squared.
Okay, I don't know how you got any of that.
Okay, just save it there and I'll go over it with you.
How you get the negative 9?
Negative 9, because x squared canceled totally, and 3 times 3 is 9.
Like, can't you cancel the 3?
No.
No, there's no 3 on the bottom to cancel it.
Okay.
Remember, to cancel, one has to be on top, one has to be on bottom. Now, what would I have to do to solve this? That would be might factor, but I'd have to take out a negative first to find out. You see what I'm saying? So the quadratic, -1, 6, -9. So the opposite of b, plus or minus b squared, minus 4 times a times c, over 2 times a. It does factor, because this is going to go to 0, isn't it? 4 times 9 is 36, then it'll be minus 36. So I get 0. Does anybody else get 0 under the radical? So if we did take out that negative, we'd have been fine. So we've got negative 6 plus 0 divided by negative 2, and negative 6 minus 0 divided by negative 2. Which, don't we get the same answer, 3 and 3? Which, that would be it. So all we need to say is x equals 3, because it won't be twice. Okay, what's next on the list?
Same basis solved.
Oh, now this is for day 2 of the final, right? Isn't that where I drew the line?
Yes.
Okay, so this should be going quite, a little bit quicker for you. So if I were to have 25 to the x plus 2 equals 1, no, let's make it 5 to the x minus 4. Solve by same basis. What's another way of writing 25? 5 squared. So when you raise the power to another power, you multiply. So 2x and 2 times 2 is 4. Now my bases are the same, so what do? Cancel the bases. So the key thing, get it to be the same bases, cancel the bases, work only with the exponents. What would I do to solve that?
Subtract the 2x.
Or subtract x?
Yeah, subtract x. So the x plus 4 subtract 4. X equals -8.
Is everybody agreeable there? Okay, same bases, is that okay for it?
Yeah.
What's next?
Rewrite an exponential form and solve.
Exponential form. Let's see. Remember 2 cubed equals 8, and the log of 8 base 2 equals 3. That's always a good thing to remember. That helps you change back and forth. And I just wrote that on there for effect there. Let's equals.
What you read about it?
I just said it's a good thing to know. Isn't 2 to the third equal to 8? And written in log form, remember how we practiced rewriting? It's the same as log of 8 base 2 equals 3. Look where everything is so that you put them in the right location when you do the process. Now, what would I do to rewrite? Remember these 3 problems, you need to rewrite it. So how will I rewrite this one?
X cubed equals 27. You take the cube root if you wanted to.
Take the cube root of each,
And you equal 3.
so x equals 30. Let's do one more for good measure.
Yeah.
Let's go log of base 5 of x equals 5. No, let's do 4. So it's a different number.
So it'll be 5 equals x.
What would I do to solve it?
5
You
times
take 5
5
times
times
So take 5 times 5 times 5 times 5?
25 times 25 is 265. Yeah.
Okay, what's next?
Solve using logs.
Okay, this is where you have to use logs, so somebody needs a calculator out to help me out here. Not yours, Spencer?
It's stupid calculator.
Let's make it -1, so we have more information there. The reason I can't do same bases is 3 and 4, I can change 4, but I can't change 3. Does everybody see what I'm saying there?
No.
So you need to write this in log form, which would be x plus 2, log of 3, equals x minus 1, log of 4.
I don't understand what you're saying.
The exponent goes in front of log of 3.
They're same basis thing you're talking
You can't do same bases because 3 and 4 can't become the same. 4 I could change to 2 squared, but it's not going to help me because 3 is not going to change to a 2. So you have to use log form. There's one problem you have to use log form on. Now, what do you need? You need your log key on your calculator. What's the log of 3? 771?
Yep.
And the log of 4? 6020?
6020.
And all I did was put it in front to make it easier, because what do I need to do now?
Oh, fine.
Distribute, and get rid of the parentheses, follow your order of operations, we need to go here. 0.4771x plus 2, 4, carry 1, 5, carry 1, 0.9542.
Yeah, that's what I got.
what would we do?
Subtract the, or add this point.
I think I'd subtract 4771, the smaller one first. You guys can do the work for me. So that cancels, I get 0.9542 equals,
0.121.
yeah, that's what I get to.
4.9.
Yeah, 4, not, that's a 4.
And then you add a point 6.
020.
Yeah.
So 265, 1.5.
And then divide the point 1249 from the 145. That one right there.
So somebody tell me what you get.
Next.
12.459.
Anybody else get that?
Yeah.
Would you want us to put the approximated sign on that?
Yeah, that would be approximate. If you didn't put it, I wouldn't count it against you, but that's what it is. Okay, what's next on the test?
One compound.
Compound interest?
Oh, a compound, PERT. And the formula's on the test. Let's say I want to invest $1,000 at 8% interest, and I want to know how long I have to invest it until it's worth $3,000. I didn't write it in a sentence form, I just kind of gave you the basics. Does everybody follow what I'm saying?
Yeah.
On the test, it's in sentence form, but here I'm trying to save time.
So at A equals 300, 2,000.
3,000, so A is 3,000. Principal, my investment's 1,000. Interest rate, remember you changed
8%.
this to a decimal,
So 0.08.
and we don't know T. What would we do to solve it?
Divide by 1,000.
Divide by 1,000.
3.
Where's my variable?
And the power.
That means logs, right? Which log do I want?
Natural.
Natural, because we got E.
I can do that.
So natural log of 3 equals 0.08 T, natural log of E. Does anybody remember what natural log of E is?
No.
It's 1. That's why natural log is always easiest to work with. You have less work, basically. So natural log of 3 divided by 0.8 would be our answer, right?
0.08.
Yeah, 0.08, thank you. 7326 years. And that again is approximate. What's next?
I need to see.
Matrices? Oh, well, we're to the point now where if we don't get, you should be good, right? Okay, do you need me to write down how to add matrices?
We'll do the whole file over.
What now?
The whole file over adding it.
Oh, you want, well, I thought you told me you wanted 2 by 2 determinants at one time.
We need those. A lot of those.
Okay, so you guys are okay on adding. Do you guys want to practice some multiplication?
No.
You okay?
The inverse.
You want to practice, well, let's do an inverse and then let's do a multiplication.
So we're doing inverse.
Let's do an inverse. Let's call this A. I'll go ahead and do a multiplication because you guys, some of you need practice.
Okay.
I want to find the inverse matrix. What do I do to find the inverse matrix?
You just
On the determinant.
Determinant.
Yeah.
So it'd be 12, subtract a negative 15.
1 over 27, and then switch and change sides.
Switch those two and change the signs. Is everybody good on the inverse?
Oh, yeah.
Yeah.
Can I multiply A times B? A is a 2 by 2, B is a 2 by 3. Can I multiply them?
Yes.
Yes. And how do we multiply matrices?
Over and down.
Row by
Column.
column. Okay, so row one, let's see, Robert, I'll have you start us. Row one, column one.
Yeah, row one, column one would be 2 times, well, 4 plus 12.
Nathan, can you do row one, column two?
2 plus 18.
Good. Let's see. Dylan, can you do row one, column three?
6 plus 15.
Nicholas, can you do row two, column one?
Negative 10 minus 20.
Okay, try that one again. I agree with the negative 10, but remember,
I get the same thing. Plus 24.
that's good. And let's see, Spencer, what about row two, column two?
Negative 5 plus 36.
And Josie, row two, column three.
Negative 15
Plus what?
30.
Thank you. 16, 20.
21, 14, 31, 15.
Okay, so we can add, we can multiply, we can do inverse matrices. Okay? Is next the 2 by 2s?
Yeah.
What about the 3 by 3s? Are you guys okay on 3 by 3s?
Wait, do you want to know what?
Yeah? You want expansion of a minor?
Yeah.
Sure.
Yes. Well, that was about the 6. And I always like to expand around the first column. So it's 8 times what?
I got it.
Adlin, what would it be?
Oh, right, that's just, so wait, can we do the diagonal?
You can, but I'm only gonna show it.
It would be 4, 6, 1, 2.
What would the next one be? Tatum, 3 times,
2, 1,
negative 1.
2,
2, negative 1, 1, 2.
Yeah, 2, negative 1, 1,
And we always remember to change the sign of the one in the middle.
2.
Okay, and Mary Lynn, what about the last one? 5 times what?
2, negative 1, 4, 6.
Okay, Riley, you get to evaluate the first one.
That would be 8 minus 6, 8 times 2.
And then the next one, Carissa,
4 minus 1.
a negative 1.
Negative 1.
So that'll make that 5.
Yeah.
And Robert, we're to you.
So that'd be 5 plus, that'd be 12 minus negative 4.
That'd be what, 16?
Yes.
So 16 minus 15 plus 80. I get 81.
Yeah.
Okay, then the next one is Kramer's rule.
Yeah.
Yeah.
You guys okay there? Need an example?
I don't think it's fine.
I think.
Yeah, we got time.
Let's do it.
You guys want time for Kramer's?
Yeah.
Because it's just a 2 by 2 quick one. Let's do one that's not nice. 6x minus 5y equals 12. And x plus 4y equals 13. So first, what's the denominator going to be of x and y?
It'd be 6, 1, 8, 5, 4. And so it'd be 24 minus 5, 29.
29? I'm just trying to go fast so we can get it in. Numerator for x,
Each should be 12 and 13.
replace your x column with 12 and 13.
And that'd be negative 5, 4.
So 48 minus a negative 65.
Yeah.
113. Numerator of y, you replace the y column with 12 and 13. 66. And our answer, the denominator is 29, 113, and 66. I don't think anything goes in any of them.
Nope.
Nope.
So there would be our answer, right?
Yep.
I said it wasn't gonna be nice. Okay, what's left is,
Determine the.
oh,
Determine if it's over.
so you gotta tell me what it is first, if it's arithmetic or geometric.
Yep.
So if I were to have this, what is it? Is it arithmetic or geometric?
At this
Why?
time, I need junior high students and teachers to the commons area for the award ceremony.
So that would be the first thing you'd say. Then if I said find A of 80, what would you do? Put it into this formula, right? You guys okay on that section?
Yeah.
And if I asked you to find the sum, then you would do, which I do, you'd use that formula, okay? And then the other one is, one of them's geometric and one of them's arithmetic, basically. You just gotta figure out which one's which and then use your formulas. Yes,
Are you keeping those formulas up
they're
there?
staying up there.
Okay.
Pass them down.
So, quickly, we got it covered, right?
Yes.
Okay, now tomorrow for you guys, since they have to watch the video tomorrow, you guys can bring that review sheet